Hello everyone. Today we are going to discuss about the probability distribution functions. In my last video I had discussed about the different type of the probability distributions. What are the probability distribution we use in statistics? So today we are going to discuss about the probability distribution functions. So let's start. In statistics we have basically two type of the probability distribution functions. First one is your probability mass function and second one is your probability density function. This is called a probability mass function and this is called a probability density function. So basically probability mass function we use for the random discrete variable and probability density function we use for continuous random variables. So let's discuss one by one. So what is the probability mass function? Probability mass function gives you the probabilities for discrete random variable and sometimes it is also called as a discrete density functions. So if you want to know what is the probability mass function, probability mass function gives you the probabilities for discrete random variables and it is also sometimes called as a discrete density function. So what is the discrete random variable? If you want to know discrete random variable, you can check my previous video. So let's understand what is the probability mass function. Let's have one example here. So when we throw a dice, so what are the possible outcomes we can get? We can get 1, 2, 3, 4, 5 and 6. These are the possible outcomes we can get. So if you want to display these possible outcomes, so you can use probability distribution as we had discussed in our last video, this type of. So what is the probability of getting 1? If we want to calculate the probability of getting 1, that is the 1 by 6. What is the probability of getting 2? That is also a 1 by 6. So same way we can calculate probability of getting 6 is also a 1 by 6. These values are called as a sample space because we want what will be the possible output at top of dice when we throw. So this way this is called as a total possible outcomes and this is also called as a sample space. Let's draw all these probabilities. So we can use, this is your 1 by 6. So this is called as a f of x function. This function is called as a probability mass function. We will discuss how it comes, but first let me draw this. This is your probability 1 by 6 and this is your 1, 2, 3, 4, 5 and 6. So this would be your, like this is your 1, this is your 2, this is your 3, this is your 4, this is your 5 and this is your 6. Probability for all the possible outcomes is equal to 1 by 6. So this is called as this whole thing is called as a probability mass function. By using this function we can get probabilities for all the possible outcomes. If we want to know what is the probability of 1, we can get 1 by 6. So this way we can get all the probabilities of only all these possible outcomes. This is called as a probability mass function. We have some properties for this probability mass function. First one is that this f of x will be lie between 0 and 1. As we know, probabilities always lie between 0 and 1. So this is also a probability. f(x) is also a probability function. Value of this probability mass function will also lie between 0 and 1. This is your first property, and second property is if we add all the probabilities, like for any, we have a data set. Okay, in this data set there are 10 values, 1 2 3. If we know the complete whole probability of this data set, that probability would be 1. So same way here, the second property tells us if we sum up all the probabilities, like xi means all the possible outcomes, then this fx xi would equal to 1. It means if we add all the probabilities, then total probability would be equal to 1. So let's verify this. If we know the fx first, so this probability is 1 by 6, then fx2, the probability is also 1 by 6. So this way we have all the fx6, we have probability 1 by 6. If we sum up all these, so let's, like 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So total we have 6. So 6 divided by 6, this would be equal to 1. So it's verified that the complete probability would be equal to 1. There are the two properties. If any data set follow these two things, then that will be treated as a probability mass function.